Hey guys, time for a quick conversation about the theory of island biogeography. So we're going to jump right into our PowerPoint here and talk about some of these concepts. All right, so we talked about this a little bit earlier already about the fact that richness declines as we go from the equator to the pole. There's a couple of reasons for that. One is evolutionary history. Life began close to the equator, and so those regions close to the equator have just had longer to evolve more different species. And then the other reason, of course, is climate. Near the equator, there is plentiful sun, which means that we have lots of energy for primary producers. There's also plentiful rain, which means that we have lots of resources for those same primary producers. And so the climate, therefore, is more rich in potential for the number of species. So the other way that we talk about species richness changing is then by distances or areas. And so if we look at a sample size, the larger the area we sample, no shock here, the greater the number of species. Okay, so if we look at an island, most islands are relatively small. And so the species richness on islands is going to depend on a couple of things. First of all, it's going to depend on the rate of immigration to the island, the number of species coming into the island. And of course, it's also going to depend on the rate of the extinction on the island. So how many of those species that get there can survive? And those two things are going to depend, especially when we talk about immigration, on island size and on the distance from the mainland. So, the larger the island, the more species it can support, the more likely a species is going to be able to land on that island. And of course, the closer to the mainland that island is, the easier it is for things to travel. So let's talk about how species can travel to islands. So whether intentionally or unintentionally, humans certainly carry species from one place to another. We have the cautionary tales of exploration by early explorers in the 14 and 1500s, where they discovered islands and there were rats on board their ships or dogs on board their ships that got off and when they made landfall on different islands, and that those species then wiped out the native species. And so there are a number of animals that went extinct because they were evolved to live on islands without predators, and when predators were introduced accidentally by humans, those species went extinct. Another way that species move from one area to another is by other animals. Seeds are a great example of this. Many of them have burrs or stickers that make them catch in animals' fur, and then they are shed later on in a different area. Or you have seeds that are consumed by animals, and then they're deposited in their scat, which gives them an ideal growing environment because it's moist and it has fertilizer readily available to it. Species can also be spread by wind or by ocean currents. Occasionally we have what are called land bridges. So as oceans recede in times of greater ice ages, then sometimes land bridges appear. And then, of course, there are what we call stepping stone islands. So as ocean levels fall, sometimes there are small islands that come up above the surface of the ocean, and this allows transportation. Okay. What makes an island able to be colonized? There's an opening, there's a niche, there's a space that that particular species can live in. Also, one of the things that allows colonization is that there's no competition. We talked a few minutes ago about those invasive species. So when rats arrived on islands, if there were no other rodents on those islands, they had no competitions for those resources. And so they were able to spread really, really quickly. Another thing that allows for colonization is if the species that are already on that island, what we call the endemic species, are not utilizing a particular resource, then that leaves an opening for a new species. And then, of course, accessibility. So what does accessibility come down to? Accessibility comes down to distance from the mainland, distance that those species have to travel in order to get to the island. Okay, so here's our theory of island biogeography, kind of in a nutshell. It says that immigration rate decreases as the island diversity increases. And this isn't saying that there are fewer animals or fewer organisms arriving. It's simply saying that even if the same number of organisms are arriving, there are going to be fewer new species arriving because the species are already there. So if we imagine a deserted island and I am wrecked and I arrive on that island and I have myself, my dog, and a pet lizard. There are now 3 species on that island. If another boat shipwrecks on that island and there's a person and a cat on it, we've only introduced 1 new species. So that immigration rate is talking about number of species, not number of organisms. So that decreases as the island diversity increases. The flip side is that as island diversity increases, extinction is also going to increase because there's more competition. On an island, there are limited resources. And so as we have more species, the competition is going to intensify, and those species that are less well adapted are going to go extinct. So the dodos went extinct because there was an invasive species that was a better competitor than they were. So species equilibrium, so this idea of finding balance on islands, is a balance of immigration and local extinction. So as new species come in and other species die off, then we find that equilibrium with a number of species. So as our number of species on the island goes up, immigration rates go down, extinction rates come up. So what does this mean from an ecological perspective, and what's the kind of outcome of this? Smaller islands are going to have lower total populations. This is because they have fewer resources. There's not going to be as many species because the small islands simply can't support as many species. If you have a lower population, probability of extinction is going to increase. This means that smaller islands are going to have lower species diversity. So when we look at this, we can see this is that same graph. Immigration goes down as the number of species goes up, and the extinction rate of small islands is higher than the extinction rate of large islands. In addition, if an island is further from the mainland, it's going to have a lower immigration rate. Fewer animals are going to successfully be able to immigrate across a greater distance. This also means that more distant islands have lower species diversity. So same graph, the nearer islands are going to have a higher immigration rate, the farther islands are going to have a lower immigration rate. So when we put these all together, we have this overall graph that shows that the probability of colonization, or the immigration rate, is going to be higher when you have very few species. That's going to decrease as the number of species increases. It's going to be higher for islands that are close to the mainland than it is for islands that are far from the mainland. Small islands are going to have higher rates of extinction than large islands. So that's it for the theory of island biogeography. We'll talk in class about how this relates to terrestrial islands. As always, if you have questions, let me know.